Hello everyone, welcome to this new video. So in today's video, we'll be solving the problem reverse a doubly linked list. This is an easy level problem and it's a problem of the day on Geeks for Geeks. And the topic company tags of the question are DE, Shaw and Adobe, and the topic tags are doubly linked list, and data structures. So let us go through the question. Given a doubly linked list of n elements, your task is to reverse the doubly linked list in place. Okay, so it's expected that you do not use any extra space or anything like other data structure to store and then again swap them, something like that. It's like you need to change them in place without using any extra space. And so these are some of the examples. So it's better you have some clarity about doubly linked list. We'll even see that here. All right, so and then expected time complexity to solve this is O of n and auxiliary space is O of 1 as said. And constraints, the number of nodes goes up to 10 power 4 and value of nodes goes up to 10 power 4. Fine. So this is the question. Now let us go through the examples first. So these are the examples. So before we dive further, it's better I'll give some clarity about what is a doubly linked list. Let us assume we have the nodes like 1, 2, 3, 4, 5. Okay. So what if I say it's just a linked list? If it's just a linked list, then it would be represented in this fashion. 1, and then it has 2 pointers. It's it's like two parameters, its value and the address to its next pointer. So it will be pointing like this: 2, and then 3, and then 4, and then 5. So each of the nodes is linked with each other, right? Like 2 is linked with 1, 3 is linked with 2, so on. What is doubly linked list? So doubly in the sense, doubly LL in the sense. So now when this particular one points to 2, okay, points to 2, and this particular 2 points to 3. Now 2 has another set of parameter. Initially 2 has its value and next, where next denotes the next node address. Now it has another thing called previous, which denotes the address of the previous node. So from 2 you can go to 1, you can go to 3 as well. I hope you understood. From 2 you can go to 1, you can go to 3. In linked list you cannot go to 1 from 2, that's not possible. But in doubly linked list you can go to 1 from 2, you can go to 3 from 2. Similarly 3 points to 2, so 4 and 5, and this happens, right? And you might be wondering what would be 1 and 5 having. 1 next is 2, 1 next is pointing to 2, 1 previous would be null. Okay, previous would be null. And same is the case with 5 previous. Okay, 5 previous is equal to 4, I mean 4 address. Okay, I hope people are understanding that terminology. And next would be null, because there's nothing next to 5. So if it would have been a doubly circular doubly linked list, like in the yesterday's problem of the day, so this one would be connected with 5 and 5 would be connected with 1. Alright, this would be a circular doubly linked list, but it's not circular doubly linked list, just a doubly linked list. So that's the reason 1 and 5 will not be linked. This is how it looks like. Okay. Now going through the examples that have been given, 3, 4, 5 is what it's given. Okay, so 3 points to 4 and 4 points to 5, and 4 is connected to 3 as well as 5. So from 4 you can go to 3 and from 4 you can go to 5. So this is how it looks. So now reverse it. What would you get? 5, 4, 3. Now 5 points to 4, and like this, this is how it looks. So from 5 you can go to 4, from 4 you can go to 3, and from 3 you can go to 4, from 4 you can go to 5. Alright, so this is what it happens. I hope you people understood. Similarly, second case as well. So it's just basic thing. We are just reversing the nodes and then giving the head of the node as the output. Like you must return that value. Alright, so now let us frame the approach. Okay, now let us frame the approach. Very basic understanding. You need not think much. Whatever has been asked, just do that. Okay, whatever has been asked, just do that. So use some basic common sense. Almost all of the problems of easy level, medium level can be solved by using basic common sense and good level of command on the data structures. This is what happens here as well. So let us assume I have this particular node. Let us assume this second example itself: 75, 122, 59, and 196. Okay. So when let us assume I'm standing on this particular node. I say after some drastic event that took place. Okay, I'm just standing here. Okay, let us assume I'll just draw a man over here. Let us assume it's me. I'm just seeing to my left and right initially. To my left I find 75 initially. To my right I find this particular set. Okay, so after some drastic event, some particular event that has taken place, and suddenly I say that whole linked list has been reversed. I mean, I see that situation has reversed. I say after some drastic event has took place, I say my situation is reversed. What can I say what can I infer from this statement? That your right is no more towards your right. It is in the left. Your left is no more to your left. It is in the right. I hope you people are getting it. So when I say the situation is reversed, that means there is nothing to my right that was initially there. It is the left that is there in my right now, and there's in my left I find my right. So then I say that the situation is reversed, isn't it? So when I say 122 situation is reversed, I can say that the particular thing would be looking like this. 122 right side it would be 7, and left side it would be 59 and 196. I can say this, isn't it? So when I say it has been reversed to 122, it will also be reversed to 59, isn't it? So that's the reason for 59. Before initially it would have been it is 122 to the left. Now 122 is in the right of 59 and 196 in the left of 59, but now it is 196 to the right side of 59. Now it is in the left side of 59. So this is how it happens. Similarly, when I'm standing at this particular position, okay, when I'm standing at this particular position, when I say situation is reversed, now to my right what is there? Now to my right it will be like this. It will be nothing. To my right there is nothing. Before initially to my left there is nothing, but now to my right it will be nothing, and to my left everything, but to my right initially will be there. So that is 122 and 59, okay, and then 196. Everything got reversed. Okay, everything got reversed. I hope you people understood. So everything got reversed. So this is what I say when when situation is reversed, your left is your right and your right is your left. Okay, so the same thing apply, write it in the code. Okay, well, how will I do? Let us assume like initially 75 is passed to the function, isn't it? 75 is passed to the function. I'll just erase this stuff. So when 75 is passed to the function, all right, so this is the head, right? This is the head. So I'll be taking a current pointer, node current pointer, and I'll be storing this particular 75. Okay, let us assume like this is the head. Okay, this is the head. And now what I'll be doing, as said, I'll be storing a temp. I'll be putting a temp. Initially that is null. Okay, initially that is null. So when I go when I do this particular iteration, while my current I'll be working on current. So while current, so what I'm doing is initially I'll be storing whatever that I have to my left. Okay, whatever thing I have to my left, I'll be storing in temp. So temp would be current previous. Okay, current previous. Now what will I do in current previous? In current previous, I'll be putting current next, isn't it? So current previous in the sense left side. So whatever to the right that I find, I'll be putting that in my left, isn't it? So current previous would be current next. And now what will I be putting on to my next? The temp. Current next is equal to temp, isn't it? Because temp we have stored the current previous value. Initially 75 had some previous value. Let us assume it has something, like now it is null, but still it is the pointer, right? It is some null, it is some address. So that we have stored in temp. So that particular thing will come to it right. It's right. And whatever the thing that has it to it's right in the initial stage, it will be coming to the left. So this is the left transition, this is the right transition. And your current would be current previous. Why? Because now what the same operation you'll do on 122, isn't it? Now 122 is not in your right side, is not in your next, is in your previous, is in your left side. So you'll be going to current previous. Okay, so in this fashion you'll update your current, and finally you will return temp previous. The reason being, once, see, let us assume here itself. So when you do for 122, okay, when you do for 122, your temp would be, so I'll just erase this particular thing. Okay, I'll just erase this particular thing. So now when you are on 122, so your linked list would look like this. So 122, so I'll just write with blue ink. So 122, and to its right we have 59. Okay, to its right we have 59, and to its right we have 196. Okay, 122 is still like that, but 75. So whatever the 75 that we have, its left is 122. Okay, its left is 122. Now we still need to connect 122 to its right, and we need to change 59 196 to its left. So what you'll be doing right now, this is your current, right? This is your current, this is your current, and this is your temp, temp. So in your current previous, that's to your left, you'll be putting this particular current next. So what will it happen? Your current previous, so 75 previous, 122 previous, you'll be having 59 and this particular set. Okay, this particular set, and to your right side you will be having temp, that is current next. So 75, and it will be like this, because 75 has been originally connected to 122. Now you are connecting 122 to 75 by putting 75 to its right. All right, and now here we have 196 still, and now again current would be here, and your temp is, now what is your temp? Temp is basically current. You have stored this particular current value, temp value. This is your temp, right? This is your temp now, and for the next iteration it would be temp is this, and for your next iteration your temp is this, and by this time your current would be null, and that's the reason temp previous would be this particular thing. That is the reason you return temp previous at last. I hope you people understood. When you have completed the iteration for this particular thing, your temp is this. When you complete your iteration for this particular thing, your temp is this. When you complete the iteration for this particular thing, your temp will be this, and when you complete this here, your current would be null. So that is the reason your temp is pointing here, and temp previous would be the answer. One, it's because this would be your head, right? So temp previous would be your answer. I hope you people understood why we are written temp previous. So it's a very basic question. If you just dry run on the paper, you will get a better clarity. So like this is the code. For some reasons I'm not able to submit it, but codes in Java, Python, C++ are there in the description. Please go through them, and if there are any doubts, please feel free to comment in the comment section. If you are unable to understand at any point of time, please watch the video once again. All right, it's a very easy question. I've tried to solve it O of 1 without taking any extra space, and just the basic common sense that we can easily find in the linked list stuff, isn't it? So thank you for watching, guys. Stay tuned.